Next up, Hernán.
Hello. Okay. Does it work?
Yeah, you can leave it. You can put the USB in here.
Okay, no. Okay. So today, when Sean invited me to do this, so one of the proposals was to have some kind of like tricky talks or something like that. So I was thinking, what can I say? And I actually decided to take off this. Sorry. Better? No. No? Okay. And actually, I decided to collect a couple of my own experiences when I was actually trying to either find or use or build on top of research from some other people. So I asked my question, like, what have we done in the last 10, 15 years in terms of availability, functionality, and reusability of formal memory models? So basically, I'm going to split this in three parts. So the first part is going to talk mostly about where I consider that we still have not done a very good job and we need to kind of like move forward in the directions. But not everything is bad. So there are a few success stories that I want to share, or at least what I consider success stories. And I'm going to finish to kind of like discuss what all those cases have in common and what can we learn from this to kind of like have more success stories in the future. So the first example, it was about a paper about formalizing some memory model, very nice paper. And it was not just about the formalization, but actually they have very nice empirical evaluation showing that the hardware was actually conforming to the formal model that they have. And one of the nice things is that they say like, okay, we provide all the experimental data online. So then I was in one of my roles as for those who don't know, I'm developing one tool called D'Artagnan that it can handle like many different models. And I say, cool, there's a new memory model, so let's try to actually add support to my tool with this. And then when I actually try to access the data from there, error. It's not accessible anymore. So actually what happened, it happened that this paper was developed in the context of the one PhD thesis, and eventually the PhD student graduated, he moved to a new institution, and this was not available anymore. So my claim is actually what we need is, we need permanent accessibility to this kind of like data. To be fair, this was like maybe 10 years ago, so I think that the community have made like a very nice progress in direction about like, with all these batches that we have for availability, reusability, or things like that. But for example, the ASIM batches is one of the things that they say is that in all the cases, we need to actually show some plan how we are gonna give this permanent access to the stuff. And they actually say that personal web pages should not be the solution that we use. Another example, a few months ago, I was attending a workshop where someone was actually giving a presentation on their verification efforts for some library that was supposed to be running on top of some weak memory models. And at some point, the presenter was claiming like, okay, for this particular API, we need this fencing here to make the code correct. And the funny thing was that, so this person was mostly talking about the verification efforts, but both the library was done by someone else, and the memory model formalizing was even from some other group. And actually, the developer of the library was actually in the audience, and she was saying, like, actually, I think that you're wrong. I don't think that you need that strong a barrier. I think that you can get away with something weaker. And there was a very long discussion during the workshop, and there was not a real conclusion about this. And even there was even worse. So someone was actually asking, like, okay, but really, like, what model are you referring to? So because there are different versions of the model, what kind of like semantics are you really using? And not even that was clear. And I think that here there were two problems. First of all, for some models, we still lack tool support even for answering very simple questions. So I think that if we have tool support in this, answering if the code is correct with or without this barrier should be kind of like trivial or very easy. And the second one is that sometimes we have way too many models, and we don't have a clue how those models relate. So is one weaker than the other? Are they equivalent? Like, sometimes we don't have a clue. My claim here is that what we actually need, first we need executable models, so then we can actually build tools that can actually answer this question for us. Another example, similar story as the first one, new paper on some weak memory model. one of the nice things, like there were many examples in there, and there was this piece of code, and they were saying like, okay, for this particular piece of code, the code is going to be correct according to this model that we are defining. And one of the good things is that this new model was actually coming with a tool. So again, I say, okay, I want to add support to this new model to my tool. And when I was actually trying the examples, yeah, my tool was saying like, yeah, according to that model, the program is wrong. And I was like, what the hell? Like, what am I doing wrong? So it was like very litmus test, small litmus test, so there has to be something stupid that I'm doing. It took me a while, but actually at some point I said like, okay, let's see what the other tool says. And actually realized, okay, actually their tool also said that it's wrong, so maybe I'm not wrong. So I contact the maintainer and I was like, hey, look, there is this paper, there is your tool, the paper claimed this, but the tools tell me something different. And actually he said, oh yeah, by the way, actually we are not really implementing this memory model, it's a slightly variation of that. So here the problem is that in many of, so there are some tools available, but the problem is that the memory code is hard-coded on that and sometimes it's obscure. And this is in line with what Luke just said, that we need kind of like this support parametric stuff. And this is exactly my need. So we need tools that hopefully are up to date with the memory model. So some memory models are evolving or adding new features. And hopefully, like even if we have like a tool that is completely parametric, like that would be amazing. Another one, new model, again, same things. There was one initial version, then there was another version that was kind of like building on top of that with some new features. There was some tool support for one of the tools, but there were only like around 100 litmus tests for a reason about that. And I say, okay, let's try to write a few more litmus tests to take a look like what happened. And I took a look to the literature, write some litmus tests. I took a look to the spec, and I found another, like there was a missing message passage, trivial stuff. Cool, according to both to the natural specification and to the first model, this thing should pass. But then when I ran it with the second one, actually it was failing. So what was the problem? So there were a few things in there. First of all, the natural specification was a little bit ambiguous about this new feature that was adding how those interacted with the fences. Second problem, there were not many litmus tests. So actually, this was not catch because there were basically not litmus tests for that. Another problem is that there were no tools for actually to compare the both examples. So we could not do any kind of like regression. The need is actually we need more validation of the model, core empirical validation. So we have some talks about this in the past. Final failure story. So as was discussed earlier today, at some point there was like in this security stuff, these Spectre attacks where actually people were showing that due to speculative execution, you could actually like have some attacks, and basically were a ton of papers after that, like focusing on operational semantics for modeling this kind of like things. And then at some point I wrote a paper about how to use axiomatic semantics to model this kind of like things. And at some point, one of the things that I wanted to do is, when I was trying to talk with security people, like none of them could really understand axiomatic models. So they mostly were thinking in terms of operational models. So I was trying to think like, okay, would it be possible to actually show them formally that actually my semantics are equivalent to some of those operational ones? And I know that there is a bunch of people in here that have done that extensively, so it's definitely doing it. I have no clue how to do that. And when I was actually trying to take a look, like, how should I do that, I could not find much information. So I would have liked to be able to reuse some, or even take a look to some mechanized proof to get an idea of like where to start. But I could not find this kind of like things. And particularly, I would imagine that there are many of those things that you can reuse from one case to another. So it would be really nice to have those things in a way that we can reuse. So we need to make all these kind of things both available and reusable. Yeah?
I don't believe in that. I think these proofs of equivalence, they're like some arcane art. There's like one guy who's written one proof and another guy that has written another proof, and we don't know how to do these things in any kind of reusable way.
So you say that you don't believe that there is a way, in such a way that we can reuse this kind of like stuff?
I don't think we know how to do that yet.
Okay, yeah, maybe you're completely right. I don't know, but I would argue that...
And mechanizing them is really hard.
Pardon?
Mechanizing them is really hard.
but okay, maybe I'm wrong, as I say, so I have no clue about this kind of stuff. I never did this, but I could imagine that there are many things that you can share between proofs. At least, for example, formalizing, I don't know, if you're talking about axiomatic semantics, the basic stuff, like what is an event, what is a read from, all this kind of like stuff, could be reused, I would imagine.
I'd suggest you talk with Gil and with Thibaut and with other people who've had some experience doing that, but maybe not now.
I can, just come talk to me, I think.
Okay, but as I say, like, not everything is bad, so I think that we have some success stories also in the community. And I'm going to talk about some of the cases that I think like shine on top of the others. So I think that the formalization of the RISC-V memory model is one of these cases. So as far as I know, at some point there was this the spec of RISC-V, and it was actually allowing a bunch of like some weak memory models behaviors, and some people in Princeton actually started to try to formalize this, and they were actually showed that it was impossible to correctly implement the compilation from C11 to RISC-V. So actually what ended up happening is that they ended up working together to kind of like formalize these kind of like things. And these are a rough, tough line of how things kind of like evolve, and I'm going to talk a little bit more like by the end of this. So basically, these people started by trying to develop some tools to prove some things. Eventually, when they have some tools that were like in some nice state, they say, okay, let's try to apply this to some real specification. Obviously, you need a bunch of litmus tests to be able to kind of, because at the end of the day, we also have some kind of like bounded verification or kind of like testing stuff, so you need to generate a lot of litmus tests. They found some issues. They communicated with the maintainers of the specification. There was some acknowledgments that, okay, there's problem in here, we work together, we fix. Eventually, they publish a paper, and then the RISC-V Foundation formed a task force to actually create a formal specification of RISC-V. And why I do consider this a success story, one of the reasons, like, this was finally accepted by the RISC Foundation. So if you take a look to the specification of RISC-V, there is one section talking about the memory model, and you have like different formal models for that. And also one nice thing is that this memory model is not only used by the people who develop the model, but also by some external people. So if you take a look to, for example, the Her repository, that is one of the tools that allow you to reason about these kind of like things, there are some pull requests or issues raised by external people, like trying to ask, like, how do I use this? Or I found these things that I'm not sure if it's correct or not. Second success story, the ARM memory model. Same thing, there's a very nice paper about the ARM's effort in formalizing their memory model. Actually, at the same time, right now, we have downstairs a tutorial from the ARM team explaining their efforts on trying to keep this formal. And so what is the timeline that they follow? And here you will see that, because actually I think that they have done several things, so pretty much they follow the same recipe for all of these new features that they want to add. So either they keep developing or they extend the tools that they already have to work with this. They apply the tools to formalize the memory, the specification. Again, you need to generate a bunch of litmus tests. One of the good things is that they keep a promise that they're going to be keeping in sync both the axiomatic. Actually, they have a few axiomatic memory models and operational ones. So they keep a promise that they're going to keep proving the equivalence between those. They talk with the stakeholder to eventually get accepted of these kind of like things, and they publish. Why this is a success from my point of view? Okay, first of all, like, I'm really happy to see industry spending effort and money in creating a whole team to maintain this kind of like things. So they see value on this. They also have this, I think this quote was coming from the paper, where they actually say that we promise to do our best to keep the equivalence, proving the equivalence between the models, and they have done extensive validation on anything new that they develop. And the final case, the final success story, from my point of view, is the Linux kernel memory model. Again, there is a very nice paper about this, which actually tries to formalize what it was in this document from the Linux kernel, which I heard a story. I'm not sure if it's true. Maybe Paul can say it. So I heard that Paul at some point was visiting UK. I think it was Oxford, and he saw in one desk this document printed with a bunch of like marks and notes and things like that. And it was actually Shad actually trying to formalize this. And this is how actually this paper kind of like started and came to life. This is true? Good. So what was the
first evidence I had that somebody had read that document front to back with intent to understand it.
Good. Yeah, so what was the timeline here? Okay, first you need to write this infamous document, actually. Then we also need, again, we need to use the tools and actually some methodologies, and I'm going to mention this in 1 second again. What do I mean by this? To actually analyze these memory models. You try to formalize the spec. You need, again, the litmus test. You communicate with the maintainers, try to get them feedback, accept or not whatever you're proposing, and eventually you publish. Why this is a success story? Okay, first of all, the Linux kernel formal memory model is part of the Linux kernel, so this was a big win. It has been extended by external people, and this is related to this thing about the methodology that I say. So actually, there was this first version of the memory model, and actually, a while ago, one of my colleagues started to taking a look to that, and he was not very happy about how let's say, the shape of the memory model. So he actually believed that it was, when this was designed, it was not following what he called a nice methodology of defining a memory model. So actually, following his methodology, he actually do some kind of like changes to the memory model that he communicated to the maintainers. Some of them were eventually accepted, some of them not for whatever reason. But for me, one of the reasons that you have external people, and by external people, I mean like people that were not initially in the group that developed this, who were actually able to contribute to this kind of like stuff. And probably for me, like the main win of this is that this memory model has been extensively, for whatever extensively means, used by people who might not necessarily be expert in weak memory models. So a lot of kernel developers, if you take a look to the Linux kernel mailing list, every now and then you're going to see people, developers saying, oh, there is some problem with this code, and here is the small litmus test that I ran with Herd, and this is what Herd says. So I think this is a big success. So what all these 3 stories have in common? First of all, everything is open source. So actually, by having seen everything open source, you allow that anybody can comment or criticize your work, but also people can build on top of that. So I think this is very nice. We have tool support for this, and I think this is very, very important because it doesn't matter how smart you are going to always miss a corner case. So I think that you really need to have some tools that allow you to reason this. And actually, within the group of people that I work, we come up with something that we call the Dyer principle. That actually means D'Artagnan is always right. I cannot tell you how many times we try to do something and we were getting wrong results, and we say, oh, we have a bug in the tool. And then we always realize that it's our fault. The tool is correct. The tool is telling you, according to the model that you gave me, this is the outcome. Maybe there's a problem in the model or whatever, but this is what the model says. All of the cases were also collaboration between academia and industry. I think this is very important because particularly academia and industry not necessarily have the same goals always. And also validation is very important. So we have some established validation technologies, or methodologies. We have Basilides spoke today, Luke mentioned something. Reese is going to be speaking. I'm not sure if he's going to be talking about that part of his work, but he also did some very nice work on validating CPU memory models. So we have the methodologies in there. However, what kind of like thing we can still improve? About open sourcing, I don't know, something that, I don't know if this would make sense, but would it make sense to maybe have some kind of like centralized repository where we have our models in there available for everybody and people could comment? This is something that I have seen in other communities, maybe different, but in these competition communities where things are completely available and can people build on that, there are some success stories in there, so maybe it would make sense. I think it's very hard, so I think there are also some problems, so I don't know what, yes, Paul?
So we have our model actually in the Linux kernel source code, and that will be the source of truth, okay? But if you want to, it's easy, it's on Git, right? You could just pull it down and put it wherever you want, and that'd be great, as long as you keep it up to date, right?
Well, yeah, exactly. This is another problem.
Not as changing that fast at this point.
Keeping things up to date, or I would even say that some people are not even aware that some things are kind of like progressing or whatever. So I'm not saying this is the answer. I don't know. I think that this brings also like a lot of challenges. Like, who is going to be maintaining this? Like, this is a lot of work, and I know that some people are not willing to do this.
In the particular case of Linux kernel source code, if somebody is willing to just grab the thing every release and put it somewhere, that's fine. Or even have a pointer to it, whatever. I mean, that's fine. The source of truth will remain in the
the
source code. But if somebody wants to pull it into a place where people can find it easily, great.
Yeah, I would like to add a bit about the centralized community repo. It would be really nice if we'll make some effort to have like common Coq library for mechanizing stuff. Because like from time to time it's extremely annoying. Then we want to extend like our IMM framework to have another compilation correctness result, and we have to like redo some work and adapt someone's Coq project which is like not compiling, or like compiling only with old versions of Coq. Yeah.
This was related to what was discussed before, that in my naive believing, like, I think that part of them should be achievable, that we can share this kind of, and it would be really nice to have this in a centralized way that people are, like, I don't know, like, we keep it updated with the latest Coq version or all these kind of like things. That it would be great if this could be like a community effort. Yeah, and this is where I mean also like having common interfaces. Like, for example, for defined axiomatic models, like I think there is a common interface of CAT. I would argue that this kind of like the language that maybe with some variation, but pretty much everybody's using this.
So, and you've got about a minute left of your time.
Okay, so I'm almost there. Okay.
2 questions waiting for you. So if you want the questions or to...
Let me finish. I just only have 2 minutes bullet point. About collaboration between academia and industry, I think we are doing great in here. And if you see like affiliations of the speakers today, it's very even, so very good in here. And as I say, about the methodology for validation. So we have a bunch of things in there. It's just that maybe we don't always use it. And I think we should make use of that. And with that, I finalize. Thank you very much.
Hi. 2 comments or questions. So in one of your slides, you said that there is a lack of tools of comparing 2 different memory models. I think in this space, actually, John has some work, Memalloy, which you can provide that to memory models, and it can give you an example which actually differs these 2.
Great tool, but unfortunately, last time it was updated, it was 6 years ago. So if you try to use it, like, you have some issues. I have tried, so I know.
Okay.
I have not tried. I know that since a couple of months it's available. I have not tried, to be honest.
Okay. I want to add one comment to one of your success stories, the second one about the ARM memory model. So actually we found it's a kind of a problem in the memory model. We actually identified some revisions. We reported that to the people who wrote this paper, and I'm happy that they accepted that change and the model is now revised.
Exactly, and you managed to do that because everything was online and available and you can build on top of that.
Exactly. And if you look at our FOWM'23 paper, it is explained in details.
Very quick Peter question.
Very quick Peter question. That's not possible. So I kind of obviously I would agree with all of the things that you want. I want all the things that you want, but let me say 2 things. So one thing is you can ask people for things, like, you know, Christopher Poulter, who I think is not here today, but you know, he did some of these proofs that you're talking about. You can talk to him. It's allowed. The other thing I want to say is, you know, all of these things are expensive in effort, you know, to maintain, and none of them ever can be expected to be stable. Right? So Thibaut will talk later about, you know, some effort to build some Coq definitions that we hope to be reusable. But each time anyone considers some significantly new feature, they need changes to tools, changes to the underlying meta language, changes to formal definitions. It's not feasible to expect all of that to be kept in sync all the time. So I agree, we'd like to have as much of that as possible, but
I completely agree, and I know that this is very hard, but I would argue like pretty much everybody that I know working with memory model is probably in this room together. So for me, it was kind of like the perfect opportunity to at least pitch the idea, see like, does it make sense? Is people interesting? Like, is people willing to do the effort? Because as you say, it's a lot of work. I know, and not everybody may be comfortable with this kind of stuff. But I think that this was a nice platform to at least like pitch the idea and see who's interested and see what fits like it.
Wonderful. Thank you, Hernán.